can one cut stones with laser saber? How molecules are changed. If you make a molecule to explode or break on pieces with a laser or with a light, how many fragments will be created? If there are several of those, how can one find which one will be generated or in which proportions? So in the high school chemistry we had this word isomers, and if reaction creates several isomers, how do we know which of them will be generated? Ideally, it would be great to control formation of isomers by tuning the frequency or intensity of the laser and direct reaction to desired product.
And upon photoexcitation, there are several pathways. One can recombine, one can go to higher state, one can break the bond. There are also applications on not fragmentation, but photopolymerization of material that is a precursor for quantum silicon quantum nanostructures.
Upon polymerization, with time it will form black intransparent silicon, or it looks silverish if you saw actual silicon, not in nanostructures but in bulk. And we go from the transparent liquid to the solid stuff. After getting moderate success in predicting how molecules are broken, we may take a courage and predict how molecule, instead of dissociation, how they make association. Molecules of cyclohexacylane, which are similar to cyclohexane, and they associate. From molecules, from liquid precursor, you get solid silicon, like drawing circuits by pen. Right? So we try to take just two of these molecules, irradiate them by light. So we added this cooling down process. So after exciting, it relaxes. It cools down and relaxes where it can be. And if we were exciting it not very long, it returns back to original precursors. But if we go long enough, it starts forming this polymers. So a network of silicons connected in continuous stuff. It is not yet a crystalline silicon. It is a oligomer or polymer of amorphous silicon. So we demonstrate photopolymerization. If you look on electronic properties and spectrum of this stuff before polymerization, here is just broccoli plot when we have several snapshots, but they're separated in space. It is emitting in the blue UV part of the spectrum. After they associate in the polymer, there is a red shift. The emission goes to the red part of the spectrum. And it is a little too ambitious on computation. On experiment, this effect was a little more humble. So one has this just slight red shift as we go for irradiation with so many minutes. But it is a right trend experiment. So we hope by further developing of this method, of this technology, computational technology, we can predict more and more reactions, and maybe do reactions that haven't been done yet on experiment to show some predictive power.